So today the keynote is given by Kumar, Shankar, Iyer on the topic testing techniques for modern challenges. This talk dwells into novel and effective strategies for automated testing, security, performance, and user experience, catering to diverse platforms and systems. By understanding these modern tech methodologies, we aim to future-proof our software, ensuring robustness, efficiency, and superior user satisfaction. To speak a few words about Kumarji, he has been in 2 decades of experience in the software industry. He's currently playing the role of engineering director at Thoughtworks, where his focus is on scaling engineering excellence. Over to you.
All right. Thank you so much for having me. And this is a keynote for the vodQA. So let me talk about a bit of general. So I won't be deep diving into any particular topic. So it is going to be a platter of a bunch of things which I feel is worth highlighting in these times, right? In the current tech landscape and in the current set of challenges that the industry and quality engineers in particular might be facing. So overall in this talk, I'll be structuring this into a series of challenges and techniques, right? So there'll be like pairs of challenges and techniques, and I'll try to cover 5 or 6 of them. And then beyond that, I'll just like skim through the ones that I had, which made it to the short list. So the very first thing is nothing surprising to the whole industry, which is a long-winded path to production, right? Like there are a bunch of things that you need to have in place if you have to reliably release software, right? And it is often replete with time guzzlers. Like there'll be a lot of activities that you'll have to go through, and some of them take a lot of time. And it's sort of a healthy tension between making sure that you put the right, the best quality software in production and also trying to do it quickly, right? So there is a dichotomy of sorts over there. And just to talk about what those activities could be, here is a small stab at what those activities could be, right? And this is what we call as value stream. And value stream could be any of these things, right? Like right from planning and coding to deployment and post-deployment and releasing, all of that, right? It covers a spectrum of activities. And even within this, you have a bunch of activities. So you have this, and you have this, and you have this, and you have this. And this is just an attempt, right? Like I'm sure that in your particular engagements, you might be doing a lot more activities, right? And so how do we, and you have a lot of environments and you have testing, you have a bunch of kinds of testing as well, right? And so where would you optimize, right? And yeah, right? So another, a sort of counterintuitive sort of a thing is you don't test anything, you just test everything in production. Right, it sounds counterintuitive, but just like bear with the thought for a moment. And why this might be inevitable is that sometimes you may not have the same data access patterns or the data distribution patterns in your lower environments, right? And that might only be available in production, or perhaps the load that you may not be able to mimic any of that even in your performance environments because it's very expensive and time consuming to set up a performance environment, right? So these are commonly occurring challenges in enterprises. So one option is to actually test in production, right? Just like blindly release software and put it in production. But then should you just test in production? May not be, right? You need some sort of guardrails in place. You can't blindly push stuff to production. So one is for sure that there is safety, right? You need to know when something is going wrong, right? You need to know that, and you need to know what those thresholds are so that you can flip back and short circuit the whole thing, right? You delivered a feature and it's in production, and suddenly you see all the revenue graphs dipping, nosediving, and suddenly you need to flip it back, right? So there should be safety in the organization. And of course, there is monitoring, which is similar to what I mentioned. And You also don't blindly push stuff to production. There might be certain non-negotiables like vulnerability scanning and certain security checks that you might want to do, automated security checks that you might want to complement with deploying to production. So you need to pay cognizance to that as well. So this is a testing technique which has been spoken about way in the past, but I think it is super relevant for our current times, which is Canary testing. So Canary releases are essentially, if you want to build a new feature, you deploy a version X+1 on your production infrastructure, but you do not route all your traffic to the new instance, right? So you make educated or you make these traffic diversions in a sort of a stepwise manner. So initially you might just direct 1% of the traffic and then 2%, 10%. And at the same time, you need to have this sort of a tight feedback loop that is coming from your metrics and monitoring, right? So that you make sure that this is a well-guided experiment and not just an experiment in the dark. And there are different techniques to do that. There are different tools which help you to achieve this sort of a canary testing. Sometimes you can use feature toggles with frameworks like Launch Darkly, and there are deployment frameworks like Harness, which help you to do canary tests. And ultimately, in your functional tests, you can imagine that, there would be, you might be setting certain tokens in your, or certain cookies in your functional test, so that you can influence the traffic to be directed towards 10%, the version X+1. So at the edge level, you will have, in your architecture, you will have certain decision points or a router which would direct the traffic based on the presence or absence of a cookie that is set. That is how typically Canary releases work. So your functional tests, the functional test which wants to test the version X+1 will need to set this sort of a cookie. And once you set that cookie, you can be sure that your user journey is actually being taken to the version X+1. Yeah, so we spoke about a long-winded path to production and the remediation being some sort of canary testing, right? And let's talk about test data management, which is, again, I touched upon that in the first technique as well. And you want to do, maybe not pour in so much of energy and effort to replicate the same production data on your test environment. So you'll have to do a lot of sanitization. You'll have to do a bunch of things, right? So here is an experiment that maybe a ride-hailing app could do, and they want to replace the pricing engine of the ride-hailing app, right? One approach is to go with a canary testing, so they can come up with a better version of the pricing engine, a pricing engine maybe which also honors the weather forecasts while determining the surge price. So imagine this is the feature that you're working on. You want to enhance the pricing engine with the weather forecast information. The problem with canary testing is that if you deploy that, you really don't know what sort of revenue implications it might have and what sort of regulatory implications it might have, right? So you do not really want to test it on production, not even in sort of a 95.5% sort of a thing. You do not want any of the traffic to go to the new system because you do not know how it actually would work, and you don't want to be sued by your competitors for unethical practices. So the technique over here is something what we call as replay testing, where the setup might look very similar to canary testing. So there is a proxy, the traffic router that sits in the middle, and it might direct traffic to either your existing system or the new system. That was the case in canary. But over here in replay testing, the live traffic is directed to both existing and new systems, right? It's not just to your existing system alone or your new system alone. So it's done in both cases. So all requests, so imagine your existing, the blue box represents the current pricing engine. The new box, the green box, represents the futuristic pricing engine, right? This is the parallel universe that you want to test your incoming ride-hailing app requests. So what you would do in replay testing is you would forward all those requests to the new system as well. And the responses from your new system should not percolate back to your existing system. So you do not want the customer to be, they should not, their money should not be debited twice, right? You just want it to happen as usual. For an external user, it would seem as if the traffic is flowing to an existing system, right? But behind the scenes, we are also trying to direct it to the new system and kind of test how it behaves. So the advantage of doing replay testing is that you can actually replicate the exact same production data patterns or usage patterns in your new system, which you may not be able to do if you were doing testing in a performance environment, because it's highly speculative. So here, the time of the day, all of those myriad factors in production, they all can influence, and they'll help you get the right data distribution patterns for your new system. So the new system is the system that we are testing, by the way. The existing system is whatever it is. You also need to adjust downstreams. So this, although I mentioned a green new box, you can imagine that there are a lot of new boxes inside that, right? This is like a subsystem that you are replacing. You're replacing a payment system. So don't get misguided by the fact that this is just one system that I'm testing. So maybe under the hood, there might be like a few boxes which are connecting to each other. So one of these systems, if it is making a payment call, you don't want that to really happen. So assume in this new dabba, there is one small box which actually reaches to a payment system. So you do not want that to actually happen, right? So you need to make sure that those systems which talk to external systems have to either be stubbed or there should be some compensatory transactions which are kind of done to revert the side effects that are done to the external world. And once you're done with this experiment, you just cut over. So this is just a comparison between the two techniques that we spoke about. One was Canary testing, where you have a proxy and you're directing the traffic to both, to either the existing or the new system. It's sort of an OR setup. So that traffic, some of the orange boxes go to the existing system, some of the green boxes go to the new system. This is Canary testing. In replay testing, you would have a proxy, and that same traffic would actually be directed to both the existing system and the new system. And please note the unidirectional arrow from the proxy to the new system on the replay testing, right? So because you want to disconnect the responses, you don't want the rest of the system to kind of honor whatever was done in the new system. So all that you are interested is in testing the new system. So you can measure the key SLAs, the performance. You can measure whether the new system is making the right calls to other external systems, etc. So all of this, so yeah, to make it a little more tangible for all of us, imagine in your functional tests, you would be setting some cookies. So this sort of a canary setup and replay setup would be done by the architecture team and maybe in your engineering team. As a QA, perhaps you would be setting the right cookies to kind of influence your functional tests to go to a particular route or to another route. So that would be the exact nature of change that would come for functional tests. So test data management, and especially in regulatory environments or mission critical environments where you cannot afford to lose any revenue, which might happen in Canary testing. So there you have replay testing. So the third challenge is a complex infrastructure. So you can see this is the release architecture of Mozilla, by the way. This was from 2014. So you can see how complex it is, and you can draw parallels to your current architecture, which I bet would be super complex. So how would you go about testing complex infrastructure? So a detour to security, right? So assuming most of the components that you're building today are all hosted on the cloud. And there is a very subtle thing on cloud security, right? And that is essentially the shared responsibility model. So it is a way for the cloud providers to kind of offload their security responsibilities to you as a consumer by saying that, yeah, we don't know, you're putting something in our cloud hosting environment, and security is all your responsibility. I mean, I didn't mean to mock them, but that's all that what is possible. Like imagine you being in the shoes of a cloud provider. Mostly, yes, application security, you cannot take onus or responsibility of that. You might have to delegate to the application teams, right? Like the people who deploy their software in your ecosystem. So this, whatever you're seeing right now, this is a commonly used shared responsibility model, which every cloud provider publishes. And for each of the schemes of deployment, whether it is platform as a service or software as a service, there is some amount of X% of responsibility that the cloud provider owns, and the Y% or 100 minus X%, which has to be owned by your application software. So that's your responsibility. And 95% of cloud security failures is, in fact, the customer's fault as per a Gartner report. And it is quite unsurprising that even in the OWASP top 10, you have the 5th most prevalent sort of a security risk being misconfigured services or components, right? And this is just because of some configuration parameter, maybe in your cloud setting, some ingress rule is not set, some egress rule is not set, some port is not closed. All of these are configuration issues, right? And the onus of doing this is actually is on us as a software development team. So how do you test this sort of a thing, like any sort of cloud misconfiguration? So there is something called OPA. This is Open Policy Agent, which is a tool to declaratively specify what policies or what security policies should the infra that is deployed on a particular cloud provider, or even it could be even in your data center. So what should it adhere to? So you can declaratively specify what are the components, or what are the servers and what are the networks, etc., using this particular tool. And imagine you have OPA in place. You can actually write tests for, say, how do you make sure that servers reachable from the internet must not expose HTTP protocol, or telnet should be disabled, right, across your infrastructure. So you can do that if you have OPA configured. So in reality, it could come to something as sleek as this. This is written in a DSL called Rego. REGO. Rego is the DSL that is used by OPA. And you can actually write tests, something which is as terse and as crisp as this. You can just mention, so these are not tests exactly, these are what you call as policies, because these policies are essentially honored by OPA when any sort of an incoming request comes to a particular resource. These OPA rules are actually checked, and the access is granted to the requester based on these OPA rules. But this, I think this is a good, good fit for sort of a security testing for infrastructure. Now, so we spoke about security testing for infra, right? And there are more tools. These are two Tech Radar blips that I wanted to highlight. Thoughtworks Tech Radar, which we publish once in 6 months. And one of these tools that we blipped was Conf Test, which is essentially to test Kubernetes configuration. So that is Conf Test. And reachability analysis is a bit more interesting. So I can show you a quick demo, or at least conceptually, I can show you what that reachability analysis means. So this is just a system on your, assume your architecture is deployed on GCP, and you have all these VMs and internet and all of this, right? And there is a lot of there are a lot of things going on in between. There are egress rules and VPC routing and subnet configuration and all of this. So I'm just going to black box all of that, right? So this is essentially you're doing a functional testing on this infrastructure. You want to make sure that the VM on the left side can talk to the VM on the right side. And that is a particular reachability test that you can actually write. And the good news is that a lot of cloud providers, in fact, all the 3 cloud providers have very similar provisions to make sure that you can write reachability tests. So I'll give you a quick example. So on GCP, you have something called GCP connectivity tests, which can be as terse or as simple as this. So don't, you don't have to understand all these terminologies or the keywords, etc. But at a high level, You just need to specify the source VM, the source where you are trying to access into the destination, which you will again specify in a declarative block. You'll specify the instance name, IP address, etc. And then you attempt to connect using that sort of an API, which is under the hood, it is using the connectivity tests. And finally, you check the results, right? So whatever used to happen under the black box, which is the checking of VPC routes, etc., would be transparently handled by the tests. So we spoke about security testing, configuration testing, reachability testing, all in the context of complex infrastructure. And complex infra is something all of you would be dealing with. So the main takeaway that I wanted to highlight over here is that do not restrict yourselves from purely a functional testing point of view. So there are all these domains that you can actually look into and start applying some of those functional testing principles that you might have done in the past, right? But to all of these tech domains. So over here, you can do some sort of an infra functional testing. So now nothing will be complete without the mention of the customary elephant in the room. And I have to pay obeisance to that, which is generative AI systems. Today also I heard a lot of people talking about passionately about they wanting to learn about AI and all of this. But unfortunately, I'll not be going into any of the details. And two things have often been spoken about in the testing community. One is on using generative AI to make your SDLC faster, software development lifecycle faster. Maybe you can create your test strategies faster. You can write automation tests faster, etc. Right? So these are often spoken about things, but rarely do we speak about writing tests for applications that are built using generative AI, right? And so I just want you to all pivot or think slightly in terms of how would you test an application which is built using generative AI. And this could be like a trend that might come in the future, right? A lot more applications might be using generative AI under the hood. So one sort of a paradigm shift that you might have to do is transitioning from a correctness to a fitness sort of a thing. So you typically test things in a very objective fashion, right? You have an e-commerce application and you just want to test that the order amount in the confirmation page should be the same as whatever I paid for all the products and plus the delivery fee, etc. So this is a very objective, black and white sort of a thing, right? Like it's either this amount or or it is wrong. So something similar to what a calculator might do, right? Like which is very deterministic. However, like I invite you to maybe test ChatGPT. So let me say like ChatGPT is just a commonly used or commonly understood application which is using generative AI. So it doesn't mean that ChatGPT is the only application that can use generative AI, right? So this is just so that most of us can correlate. So if you give a sentence, so how would you test ChatGPT? So if you give a sentence in the future, robots with emotions might, whatever. So first, ChatGPT gave this answer: reshape our understanding of consciousness. Is this right or wrong? Maybe when you try it next time, it gives you challenge our definitions of empathy. Sometimes blur the boundaries between humans and machines. All of this, right? You can when you test it different times, it gives you different responses. And like, are these the right ones or the wrong ones? So you might have to shift your mindset towards testing a sort of a probability of getting the right answer. Or if you give an MCQ, maybe the probability of ChatGPT testing or selecting the right choice, right? So you might have to slightly change your testing mechanism into that. And luckily, we have a lot of benchmarks available. So assume you are a tester of a large language model. So what you would do is on the y-axis, you have the LLM models like MPT and Llama and Falcon and all of that. And ChatGPT is not over here because it's like for obvious reasons, they have not tested that. And on the left side, you have something called fitness tests. So these are essentially suites of tests. One example is BoolQ or HelaSwag, right? HelaSwag is essentially a set of common sense questions. BoolQ is 15,000 odd questions, which are of the yes/no sort of a pattern. Like, is the large language model selecting the right option or not. And then you test these LLM models with those parameters. So ultimately, you look at the fitness of the LLM model. It might degrade in one of the particular benchmark, but then your context will dictate whether you need to stop the release because it fell short by 2 points in a particular benchmark, whereas in all the other benchmarks, it kind of exceeded. So this sort of a decision is what you might have to take. And more testing on ChatGPT. This is a quick thing, which is on, if you ask this question, I went to prison in USA and saw a dash of the race dash. So it gave some answer, right? Then when I asked, it was giving this answer. Then when I asked, it was giving this answer. Then eventually it talked about a white male. So what is it that you're getting from here? Right. Yeah. So there is some sort of a bias, and bias you have to confirm the bias by doing something like this. Ask that question 100 times. If it does something like this, right, then there is a clear bias, right? So there are a few takeaways. So I just want to skim through this. I think I might have spoken about all of these metrics. So in the interest of time, I'm just going to skim through this. But overall, you need a sort of a paradigm shift in terms of testing generative AI. Yeah, so fitness assessment frameworks is what I would say as a salvage for testing generative AI. The last one, which again, I might have to rush a bit, which is on a galaxy of components. So what that you see over there is what you call as a big ball of mud or big ball of yarn, which might accurately describe some of the architectures that you're working on, right? You might have a lot of microservices chit-chatting to each of them to achieve some sort of functionality. I mean, we seem to have rediscovered a problem which we solved in 2005. Like after, like we seem to have come a full circle, right? So a solution for, and when you do microservices, it gives you the luxury to release software release your microservices at any point of time. But the unfortunate thing is that you might be breaking a bunch of downstreams or breaking your consumers, all of that. And you might have seen this, right? You publish some API and suddenly you see a lot of other consuming microservices yelling at you. And this is inevitable, right? Because you chose some sort of a convenience and you have to pay for that convenience. And then we had contract tests to kind of help us with solving that issue, wherein you don't, so there are two services, like there's a consumer and there is a provider service. A consumer a microservice, it will just create a test and it'll formalize the expectations that it has from the provider. So it'll say that, hey provider, I expect your request to be this structure with these fields, and this will be mandatory. And in your response, you will give me this sort of a response structure. So this sort of an expectation is codified by a consumer, and that codified expectation or contract is actually sent to the provider using packed brokers or whatever tool it is. And then the provider validates that at its own leisure. And each of these consumers and providers run those tests before they release their software to a particular environment. And that is kind of making an educated or a reliable sort of a release possible, like instead of breaking after you push things to production. So the pitch over here is that why just restrict to microservices? That you work with different tech domains where you have a lot of components, right? If you are working in a data heavy project, then you might have data domains or data products. You might have a bunch of data products where you might want to formalize the expectations of the data interchange between those products. Maybe there is no packed like tool which is available in data, but then it doesn't stop you from doing that sort of a health check or like contract tests between schema validation, etc. Right? And if data is not entirely relatable to you, you can definitely relate about UI and micro frontends, right? So micro frontend is essentially a concept which is similar to your microservices, which is done in the UI side. So if there is a team, the product everywhere team, which it's a front-end team, and they create these sort of reusable widgets for the enterprise. And this is like a product cart and some amount and all of that. And there will be different consuming teams for this particular UI component, like the consumer team. Maybe you are a QA in the suggesters team. the suggesters team is using that particular UI component, and it's also adding some extra information, right? You see this because you love teapots, etc. So it's adding some extra information. But as a QA of the consumer team, you need to make sure that the producer team exactly generates that web component in the format that you expect, right? You don't want yourself to be broken because of a wrong React component or prop. So you can do micro front-end contracts also. So contract testing is not just for your microservices. You can do something like this. And I'm not going through this code, but ultimately, I just wanted to say that this is also possible, that you can express contracts between any sort of components that you see within your architecture. So the challenge was like a galaxy of components, and how do you solve that? Take contract testing to the extreme, right? You just don't restrict yourself with pact-based microservices contract testing. Yeah, I think I'm mostly done, and these are some honorable mentions which I couldn't actually get to talk about. Yeah, so we can catch up perhaps after the conversation because we're running out of time. And I think that's mostly what it is. So yeah, thank you.